Welcome back to another tutorial. In this video, we will be discussing the Pandas library, a commonly used data manipulation tool in Python. Please leave a like and hit the subscribe button if you found this video useful. Stay tuned. Why is Pandas library so important? Pandas is an open source Python library built on top of the NumPy package that is mainly used for data manipulation and analysis. It provides many tools to speed up the data analytics process and is one of the most important tools for data scientists and for data analysts. The two primary data structures used in Pandas are series and data frames. Series is a one-dimensional labeled array capable of holding data of any type, whereas a data frame is a two-dimensional labeled data structure with columns of different types like a spreadsheet or SQL table. Okay, so now let's jump into the Jupyter notebook. To install Pandas, you can type in pip install Pandas and execute the cell, and the package will be installed. If it is already installed, it will say requirement already satisfied. Now let's import the Pandas library to our notebook. To do that, we can type in import Pandas as PD. This command will import the Pandas library as PD. We are using shorthands so that we do not have to type in the code completely when we want to import the library and also to make the code more readable. The dataset that I am using for this tutorial will be the Stack Overflow Developers Survey dataset. I'll add a link to it in the description below. Now, there are different ways to read data from a file in Jupyter Notebook. You can either import the CSV file into the Jupyter Notebook and read the data from it, or you can read the data from the directory where the CSV file is stored. To import the file into Jupyter, you can go to Jupyter, go to Uploads, and upload a CSV file. We will then use the read function in Pandas to read the data from the CSV file into a Python data frame. Here I'm going to load the data into a data frame called SO data. Stack Overflow data pd.read CSV and then execute the cell. Read CSV is a pandas function used to indicate that we are trying to read a CSV file. To display the data in the data frame, we can type in the name of the data frame that we have created. Here it's SO data. This will show the data that is loaded into a data frame using pandas. Now let's try and load the data using the second method. To do this, first we need to import the OS module. Import OS. After this, we can set the directory location to where our data is stored on the system. os.change directory, I've stored it on D drive. I'm just copying the file path. Now setting this file path will tell the software where to look for our data. We can then load the data into a data frame using the read CSV function. pd.read CSV. And to see our data, we can just type in the data frame name. Now this basically gives us a preview of the dataset. We can also preview the data in a data frame using the head function. The head function by default will show you the first 5 rows in our data frame. Stack Overflow data.head. So by default, it will show the first 5 rows in our data frame. Now if we want to see the first 10 rows instead of the first 5 rows, we can just pass the number of rows into the bracket. So this will now return the first 10 rows. As we can see, 10 rows are returned. Similarly, if you want to see the first two rows, we can just pass in the number of rows and it'll return only the first two rows. Now this is to see the initial rows. So instead of seeing the initial rows, if we want to see the last rows of our data, we can use the tail function. Data.tail. And just like the head function, by default, this will give the last 5 rows. The tail function also can be passed with or without a value. If I want to see the last 10 rows, I can just pass in and I get the last 10 rows. If I want to find the dimension of the dataset, that is, if I want to know the number of rows and columns in our dataset, I can use the shape attribute. The shape attribute gives us the number of rows and columns of our data in a tuple form. To do that, I can just type in data.shape. From this, we can infer that our data has 64,461 rows and 61 columns. Now, if you want to know more details about the dataset, such as the data type of the column, the null values, the number of entries, then we can use the info method. .info. As we can see, there are 61 columns in our data and the different data types of these objects. Also, when we look at the non-null entries, we can see that there are some columns with null values. Let us check if there are any duplicate values in our dataset. To check for duplicate values, we can use the duplicate function as follows. Data dot duplicated dot sum. So this gives us a sum of all the duplicate entries in our data frame. As you can see, this is 0 and this tells us that there are no duplicate values in our dataset. But to understand this function further, let's create a sample data frame. We have created a sample data frame with duplicate entries. Now let us try and apply the duplicate function. As we can see, it shows out our duplicate entries. We can remove the duplicate entries from the data frame using the drop duplicate function. We can check if the duplicate entries are removed by applying the function once again. It returns 0, which means that all the duplicate values are removed. As you can see from the two data frames, this data frame has all the duplicate entries removed. Now let's head back to the main dataset. Now let's try to find the count of all the null values. To do that, we can type in data dot is null dot sum. Now this will return a sum of all the null values in each column. If we don't use the sum function, it will just return a table indicating the null values without giving us a count. As we can see, a table indicating a true or false is returned. True indicates a null value and false indicates a non-null value. So let's add the sum function to get the sum of all the null values. As you can see, now we get a sum of all the null values in each column. To get the name of all the columns in a data frame, we can use column attribute. dot column. Now this gives a list of all the columns in a data frame. Now that we know there are null values in our data, let's look at how to deal with these null values. To remove a column completely from a data frame, you can use a drop function. Now say I want to remove this column from the data frame. So what I do is data dot drop data frame, the column which we want to drop the data frame, axis equal to 1 implies that we are dropping a column, and in place equal to true to remove the column from the data frame without returning us a copy. And now if we type in our data frame name, so data.info, we can see the column has been removed from our data frame. 61 columns, 60 columns. We removed this column. Another method to deal with null values is by using the fillna function. Fillna helps to replace null values or any values with another value. To understand it further, let's look at the number of null values in a column. To do that, we can just type in now we can see that there are 299 null values in this column. If I want to know the number of unique elements in this column, I can do that by typing in. Now NUnique is used to find the number of unique elements in this particular column. This tells us that there are 5 entries in this column. If I want to see these 5 unique entries, I can modify this command as unique. NUnique was to get the number of unique elements. If you type in the unique function, it will return us a unique elements from that particular column. So this now shows me the unique elements in this particular column. Now if I want to get the unique entries along with the count, I can use the value counts function. Now this returns me the unique entries along with the value count. Now that we have an idea about the column we're dealing with, we will replace the missing values with the mode, that is, the value that appears most frequently in the dataset, which in this case is this value. So what we're doing in this step is to replace all the null values in the column main branch by replacing the null values by the mode, that is the most occurring entry. Now to see if the null values are replaced, we can run the isNullSum function once again. And as we can see, all the null values are replaced. Fillna can also be used to replace null values with a value. Let us take the next column for example, hobbies. And we can see that there are 45 null values in this column. To see the unique entries, the unique entries for this column are yes, no, and NaN. For this column, we'll replace the null values with yes. To do that, now if you check the null values again, we can see that the null values are replaced. And as we can see, the unique entries are only yes and no. Another method of replacing null values using fillna is by using forward fill, ffill, or backward fill, bfill. What forward fill does is it will replace null values with the value just before it, and backward fill will replace the null values with the values after it. For showing this, I am using the next column, currency description. First, we will print the first 15 lines of this column using the head function. Now this will give us the first 15 lines of the column currency description. Now we'll replace the NaN values using forward fill method. Specify the method forward fill and in place equal to true. And we once again use the head function to see the output. And as we can see, all the NaN values are replaced by the values in front of it. NaN pound sterling replaced by pound sterling. H4. Now let's try backward fill on each column. For that, we print the first 15 lines of each column. We then use fillna with backward fill. Filling with backward fill, and once again you can use a head function. Now we can see the null values are replaced with the values after the null values, which in this case 25 is copied to the values in front of it. Now if we want to set a limit of 1 to these functions, it will change only one null value. For example, in this case, since it was 25, our three null values behind this were changed. So instead of that, if you want to change only one null value, we can set a limit to 1. To do that, I'm modifying this command equal to 1, and I'm rerunning the complete kernel. As we can see from the example, only one null value is changed and then it moves to the next null value. Now, if we want to obtain the statistical values such as count, percentile, mean, spread of the numerical data in a data frame, we can use the describe method. To see random values from the data frame, you can use the sample function and pass the number of rows which you want to sample. For example, I'm sampling 5 rows, and it randomly gives me 5 rows from our data frame. To get the n largest values from a column in the data frame, we can use the n largest function. Say I want to get the largest 5 rows from each column, I can do that by typing it as follows. N largest, the number of rows you want to display, and the column name. So this will return all the entries and order it by largest value from the column each. Similarly, to get the smallest value, we can just replace the largest by smallest. As we can see, now we have the rows with the smallest value in the column age. Say we want to find the details of all the students who are learning to code from a list of entries. To do that, we can group the entries by the main branch and then get a group of students who are learning to code. To do that, we can write the code as follows. Group by. Now we are telling the program to group all the entries by the main branch and then get the group I am a student who is learning to code from the list of entries. Get group and run the cell. As we can see, the program returns a list of all the entries There are students who are learning to code. We will now look at the common slicing operations in pandas, loc and iloc. Loc selects entries based on labels, whereas iloc selects entries based on position. If we want to create a data frame with a reduced number of entries, we can use loc or iloc to splice and store the data. Here I'm going to create a copy of the data frame with 1000 entries using loc. I'm creating a new data frame, Stack Overflow data new, Stack Overflow data dot loc. So the new data frame will have 1000 entries of the previous data frame, that is this one, from row 1 to row 1000. To see the info of the data frame, we can type in new data dot info. As you can see, we have a reduced data frame. You can do the same operation using iloc also. If we want to see the entries from row 10 to row 15, we can type in the command as follows dot log 10 to 15. Here 10 indicates the starting row and 15 indicates the last row from which the data is sliced. If you want to see the first 15 entries, you can leave the first row blank as follows. As leaving the first index blank tells a program to start from the first index, that is 0. So for creating a copy of 1000 entries, instead of slicing the row from 1 to row 1000, we can also use loc 1000 as it will slice the entries starting from row 0 to row 999, giving 1000 rows. To filter out the entries who are from United States, we can use the log function as follows. Dot log dot country, where country is a column name, country equal to United States. Now this returns all the entries which have the value United States for the column country. Now if we want to filter out the people from US with age less than 25, we can modify the command as follows. Age less than 25. Now what this will do is it will check for all the entries that have country as the United States and age less than 25 and returns the entries that match both these conditions. Log can also be used to return a specified list of columns that match a particular condition. For example, if we want to get the age, main branch, and country of the people who are under the age of 25, we can do it by using log as follows. Now, as we can see, it searches for all the entries with age less than 25 and returns the columns which we have specified, which in this case is age, main branch, and country. Now, let us look at selecting rows using iloc. Say that we want to select the 0th, 5th, 10th, and 15th row from a database. We can use the iloc function as follows. 0, 5, 10th, and 15th. Now, if you're wondering why the output is showing row number 1, 6, 11, and 16, this is because we spliced the data from 1 to 1000, and as a result, row number 1 is stored at index 0, and so on. To make it more clear, let us create a data frame by selecting the rows up to 1000. Now, this data frame will have 1000 rows starting from index 0 to index 999. And now we'll run the above command once again on this dataset. Hope this made more sense. Now, iloc can also be used to select a range of rows and a range of columns. For example, if we want to select the first 5 rows and first 5 columns of a dataset, we can do it using the iloc function. Now, this returns the first 5 entries starting from index 0. If you want to get the entries from row 2 up to row 5, we can modify this as follows. As you can see, this will return all the rows from row 2 up to row 5 and all the columns up to the fifth column. Now, if you want to limit the column as well, we can modify this command as follows. Now, this will include the rows and columns from index 2 up till 4. One notable difference between loc and iloc is with the ending index. For example, if you type in, now this will return all the rows from index 2 up till index 5, including index 5. And if we use iloc, this will return all rows from index 2 up to index 4, excluding index 5. Next, if we want to get certain columns and sort them by values, we can use the sort by values function as follows. Sort values, and by we are setting age. This will return the columns main branch, hobbyist, age, and country after sorting them by age. Now, if you want to run various queries on a data frame, we can do that by using the query function. Now, let's say we want to find the woman below the age of 23 from a data. We can write the query as follows. Dot query age less than 23 and gender equal to. As you can see, the program returns all the entries that match our query. Now let us try and find the entries that are work hours between 40 and 50 hours. As we can see, the program returns the entries that are work hours less than 50 and greater than 40. To save the data frame as a CSV file, we can use toCSV function. Reduce stack overflow data.csv and index equal to false. Now this command will save the data frame in a CSV format and the file will be saved in the location where we have set our directory. To save the file in an Excel format instead of CSV format, we can do that by using the toExcel function. toExcel xlsx, and we can give the sheet name if required. Data, and this will create and store the data in an Excel format. So far, we have looked at performing various pandas operations on data that we have imported from a CSV file. Let us now look at how to create series in data frame. To create a series, let's first import the NumPy library, as we will be dealing with ndarrays. To install NumPy, we can type in pip install NumPy. And if it is already installed, it will say requirement already satisfied. Now let's import the libraries. Let's say we have a list of alphabets and we want to convert it into series. To convert this list into series, we can just type in series is equal to pandas.series, and we can pass the list into this. The list will now be converted into a series. To print the series, we can type in print series 1, and as we can see, the series automatically assigns an index to each of the elements of the list. Similarly, we can create a series from an ndarray. To do that, first we have to declare an np array. Now we can pass this array as before to create another series. And to see it, we can print it. Just like before, we get the output along with this indices. Now let us look at how to create a series from a dictionary. Let us create a dictionary of countries along with their population and pass it to a series function. This will convert the dictionary into a series. Here we are passing the numerical values for the population of the countries, and the name of the countries are the index. This output shows the countries mapped as indexes to their respective population, and the data type is showing followed as we have entered decimal values. Now that we have learned how to create a series, let us look at how to access elements in the series. To get a particular element from a series, we can pass the element location or index. For example, if we want to return the population of India, we can just pass in country population 0 and will return the population of India as India is stored at index 0. To print a range of values from this series, we can slice a series as follows. Country population. This will return all the values from index 0 up to index 3. We can use the log function to look up a country by its name. For example, if you want to return the population of Canada, we can type in the command as follows. Now this will search for the country Canada and return its population. We can use iloc to access the data by its position. Country population dot iloc 2. This returns a population of country at index 2, which is United States. We will now look at how to perform vectorize operation in series. For this, I am going to create two series called vector series 1 and vector series 2. To add the vectors, we can use a add function. Vector series 1 dot add vector series 2. Now as we can see, we have a sum of both the vectors. Vectorized operations are performed based on index position. We got the results at index A, B, C, and D because both the series had the same index. Now, what happened if we change the index? Let's check it out. Now, here we are shuffling the index of the second series. A, C, B, D. And now let's add the both vectors. As we can see, we get a different result. What if we change the indices instead of just reordering them? Let's check it out. As we can see, the new indices will have null values as they do not have any numbers in them. To get rid of the null values, we can use a fill value. That is, if there is a new index without any value, it gets filled with a value and added to the series. To do this, we can modify the add function as follows. Here we are setting the fill value to be 0 so that if a new index is added, it will automatically take in the value 0. Similarly, we can perform vector subtraction on series by just changing the addition to subtraction. Let us now look at creating data frame from a list. First, let us create a data for our list. To convert the list to a data frame, we can just pass the list to a data frame function. We can now print the output to see the contents of our data frame. Now say that we want to add a column date of birth for our entries. To do this, we'll create a list containing the date of birth of the people in a data frame. We can give a column name for this and add the data to our data frame as follows. To see the modified data frame, we can just type in data frame list df1. As we can see, the modified data frame now contains the date of birth of the people. To check the data type of the columns in a data frame, we can use the info method. When we examine the data type, we can see that the data type of the date of birth column is shown as object. We want this to be in a datetime format. To convert the data type of the column from an object to a datetime format, we can use toDatetime function. This function will convert the data type of the column from object to datetime format. To check the data type, we can type in list df1.info once more, and as we can see, the data type of the column is modified to datetime format. Let us now look at creating a data frame from a series. To create a data frame from a series, let us create two series. The first series indicates the population of the country in millions, and the second series indicates the area of the country in million square kilometers. We can now create a data frame, country df, by passing both the series into the data frame and assign column names to the series. Our data frame has been created and we can print the data frame to see the output. In the previous section, we had seen how to obtain the largest and smallest value from a column in a data frame. Let us now look at some more statistical functions on data frame. To get the maximum value from a column in a data frame, we can use the function max, country df.max. This returns a maximum value in each column. To obtain the minimum value, we can type in country df.min. Similarly, we can use the mean function to obtain the mean, and standard deviation function to obtain the standard deviation. That brings us to the end of this video. Hope you got an idea about the different operations using Pandas library. Please leave a like and hit the subscribe button if you found this video useful. Thank you for watching and see you in the next video.